Hello and welcome to Cloudstack training. This training is divided into 5 sections: Cloud Overview, Installing Base System, Installing Cloudstack, Setting up the first cloud environment, and Cloudstack Basic Administration. If you know about Cloudstack, or in general if you are aware of what is a cloud, you can skip the Overview section and move on to Installing Base System. I would recommend that you go through the Installing Base System section, as it is the foundation for this training. Let's get started understanding what is cloud computing first. Cloud is the most common buzzword in technology today. Everyone wants to know about it, and all vendors are rebranding their products to be aligned to the cloud. Yet, the most common question that I hear is, what is actually cloud computing? So, it would be fair to start with this question. After all, it would be hard to build a cloud solution if you don't know what you're building. Unfortunately, though, it is harder to define cloud computing than you would expect. Although, if you search the internet, you will find several authoritative definitions of cloud computing. Virtually everyone and every company with interest in technology has a definition. In fact, that is the root of the problem. Without adding more confusion to the definitions, I would refer to cloud computing as hosting of your infrastructure, applications, and data with a service provider that allows you to automate administration, deployment, access through a self-service portal over the internet. Here are a few definitions that you can refer to through NIST, Wikipedia, IBM, or Salesforce.com. Although everyone has their own definition of cloud, there are 5 key characteristics of cloud computing that most agree to. This does not mean that each characteristic is essential to every cloud solution. However, typically the more features that apply to the solution, more likely are others to accept it as a cloud solution. Self-service on demand. One of the key features of the cloud is the ability to deploy resources on demand through a self-service portal that is accessed over the network, commonly the internet. Automated deployment. Another key feature of cloud solution is the ability to automate the deployment of infrastructure and the applications. Similar to the virtualization world, cloud makes this possible through templates. Templates allow for standardized rapid deployment. Rapid elasticity. One main benefit of cloud computing is the inherent scalability of the service provider, which is made available to the end user. The model goes even much further in providing an elastic provisioning mechanism so that resources can be scaled both up and down very rapidly on demand. Delivered as a service. A key differentiator of cloud computing from traditional computing environments is that the resources are delivered as a service. Similarly to service-oriented architecture that developers are familiar with, end users are offered services that they consume individually or collectively. Users don't concern themselves with what hardware is being used, who is managing it, or how many physical components make the offered service. All they care about is the quality of service delivered and the choice to consume the service on demand. Measured service. Another characteristic of cloud is its ability to granularly measure the resources used. This becomes key to accurate billing as users rapidly scale resources up and down on demand. It is similar to electric utility company measuring your electricity usage through a meter. In addition to be able to consume services on demand, one of the key features of cloud is that it allows for you to pay for use. You can equate it to electricity that you consume and pay for in your household. Users are generally charged based on the resources used, typically by the hour. For example, we can create a server in AWS or rack space, run it till needed, shut it down and destroy it when we are done, and pay only for the resources the server consumed during the time it was running. Let's look at some of these features offered by the providers and how they are consumed by the end users. There are three main services offered in the cloud: infrastructure as a service, software as a service, and a platform as a service, typically known as IaaS, SaaS, or PaaS. Infrastructure as a service delivers infrastructure such as servers, DNS, networks to the end users. Typically, an end user of this service creates a new system, a virtual machine, at a cloud provider's data center such as AWS or Rackspace. Software as a service delivers softwares to the end users that they can connect to the use over the internet connection. These are actual applications such as Office 365, QuickBooks, Google Apps, etc. Platform as a service delivers development platforms such as Java Beans, .NET to the end users. End users of these services usually are developers that are looking to leverage technologies and data offered by platform providers. Salesforce.com is the most common example of the sales platform services offered to the end users. Developers typically use APIs to develop applications and access data used by the end users. Cloud is still evolving, so there are other services that are being added to the offerings. These include backup as a service that allows users to connect to backup software online and back up their data to the service provider's data center. DR as a service, or disaster recovery as a service, that allows businesses to create replica of their environment and allow the environment to be brought up in case of disaster or loss of their primary environment. Desktop as a service that allows users to connect remote desktops, typically standardized for the end users, with all the applications and tools needed for their job function. Software storage as a service that allows users to upload and download files remotely for access, availability, and archival purposes. For example, Dropbox or SkyDrive or Google Drive or an Amazon Drive that allows you to upload files for sharing and accessibility purposes. There are three basic types of cloud models: public, private, and hybrid. A public cloud is a multi-tenant environment where shared services are offered by cloud providers to the general public over the internet. A private cloud, on the other hand, is a single-tenant environment that is accessible and used by a single entity. It could be on-premise or it could be offered by a cloud provider, such as Amazon. A hybrid environment is a combination of public and private cloud environments. It is where some services are run in multi-tenant environments and some are run in isolated environments accessible to only the subscriber of the app environment. Now that we know what is a cloud, what are its key characteristics, cloud service delivery models, types of clouds, and the basics are out of the way, let's look at what is Cloudstack. So, what is Cloudstack? Cloudstack is an open source software platform that pools computing resources to build public, private, and hybrid infrastructure as a service clouds. Cloudstack manages the network, storage, and compute nodes that make up the cloud infrastructure. You can use Cloudstack to deploy, manage, and configure cloud computing environments. We will be deploying Cloudstack to build a private cloud environment. A Cloudstack installation typically consists of two parts: the management server and the cloud infrastructure that it manages, typically the hosts. The minimum production installation consists of one machine running the Cloudstack management server and the cloud infrastructure, or a single host. In this training, we will be deploying two servers, one that will run the management server and the host services, and the other that will only run the host services. Cloudstack architecture consists of zone, pod, cluster, host, and a region. It also consists of primary and secondary storage. A zone is equivalent to a single data center. A zone consists of one or more pods and a secondary storage. A pod is nothing but one rack of hardware that includes a layer 2 switch and one or more clusters. A cluster consists of one or more hosts and primary storage. A host is a single compute node within a cluster. Hosts are where the actual cloud services are run in form of guest virtual machines. Primary storage is associated with a cluster, and it stores the disk volumes for all the VMs running on hosts in that cluster. Secondary storage is associated with a zone, and it stores templates, ISOs, images, and disk volume snapshots. Region is a geographical area that contains multiple data centers, such as north, east, south, west regions. Think of it this way. You have a north, east, south, west region. Within that region, you have data centers, multiple data centers. Within the multiple data centers, you have multiple racks called pods. Within the pods, you can have multiple clusters. And within the clusters, you could have multiple hosts. Cloudstack provides two types of network models: basic and advanced. Basic model provides a single network where tenant environments isolation can be provided through layer 3 using security groups. Security groups are simple firewalls that provide IP address source filtering. Advanced network provides the ability to create multiple networks that can be used to physically isolate the network environments for individual tenants. This network model provides the most flexibility in defining cloud guest networks. We will be installing basic network in this training. As an example, Amazon actually uses basic networking model, or they use security groups for isolation, whereas most other service providers work with advanced networks. If you're interested in learning more about Cloudstack basics, I would recommend watching this video on YouTube. Okay, now that the theory is out of the way, let us get into the actual work. We will start with installing the base system. And here are the steps that we will follow to build the environment. We will create the management virtual server. We will create host virtual server, install the operating system, update the operating system, configure the operating system, and test the connectivity. Before we start though, here's what you would need. You would need a laptop or a desktop with 16 GB RAM, at least 500 GB of free disk, at least one CPU that supports hardware virtualization. You would also need a VMware Fusion, VMware Workstation, or Oracle VirtualBox. Here are some helpful links. If you are new to Linux, you could go to tldp.org to learn more about Linux. You can download the VirtualBox from virtualbox.org. You would need to download the CentOS from centos.org before we actually start to do the installation. You can refer to the Cloudstack documentation at cloudstack.apache.org. Here is the deployment architecture that we will be building. As per the architecture, we will build two virtual machines, a management server that also runs host services, and a host server that only runs host services. Both systems will have one network adapter connected to the internet. And here is the Cloudstack architecture. We will create a basic network zone with one pod, one cluster running two hosts. We will also create a secondary storage for the zone and the primary storage for the cluster. We will build the servers as per the following specifications. Management server plus host server with 2 CPU, 4 GB RAM, 2 hard drives, one of 50, one of 200, and one network adapter. Host or the hypervisor server with 2 CPUs, 4 GB memory, and 50 GB hard drive with one network adapter. So, let's get started. To create a virtual machine, open VMware Fusion, click on plus, new, continue without disk, choose a disk or an image, select CentOS 64-bit live DVD for full install that you downloaded, click on open, click continue, make sure the operating system is set to Linux and the version set to CentOS 64-bit. Click continue, click on customize settings, type CS mhost 001 and click save. In the settings dialog box, click on hard disk to expand the drive to 50 GB. Click Apply. Now go back and click on Add Device. Click on New Hard Disk. Click Add. Change the size to 200 GB and click Apply. Next, let's change the processors and memory. Click on Processors and Memory. Click the drop down. Select 2 processors. Change the memory to 4096. Click on Advanced Options and enable hypervisor applications in this virtual machine. This enables hardware virtualization. Click the X window or close it. Click on CSM host 001 and click on Startup. While you see the automatic, click on the button or click any key. Select Install from the menu and hit Enter. Next, once CentOS gives you a screen, click on Next. Select the language and click Next. Select Keyboard Settings, click Next. Leave it to Basic Storage Devices, click Next. Click Yes to discard data. Type in CSM host 001.cloud.intr as the host name and click Next. Select the time zone and click Next. Provide the root password. Click Next. Accept weak password by clicking Use Anyway. Next, select Use All Space and click Next. We will use the 512 or 51200, which is the 50 GB disk. Select that and click the right arrow and click Next. Click Write Changes to the disk. CentOS will copy the image to the hard drive. Once the installation is complete, you will see the congratulations page. Click Close. Once the server reboots, you will be at a welcome screen. Click Forward. Click Forward to agree for the license. Create a user called CSAdmin. Description as Cloudstack admin user. Provide the password. Click Forward. Click Yes to accept the weak password if it prompts. Click on Synchronize date and time over the network. And click Forward. This will start the NTP service. Do not click Cancel. Click OK and click Finish. Once at the login prompt, click on Other, type in root, type in the root password that you set in the first installation screen, and click Login. Click Do Not Show This Again, and click Close. At the desktop, you'll be at the desktop. First thing that we need to do now is to install virtual VMware tools. To install VMware tools, click on Virtual Machine menu and click on Install VMware Tools. Click Install. At VMware Tools window, double-click the VMware Tools, click on Extract, select File System, select TMP, and click Extract. Click Quit and close the window. Click on Applications, System Tools, and open a terminal. Change directory to TMP, then change to VMware Tools Distribution. Type in /install /VMware install.pl --default and hit enter. Once the installation is complete, type in once the installation is complete, type in /usr/bin/vmware-user to start the VMware tools. Next, we will update the operating system by running yum -y update. Once the update is complete, let's go and give the csadmin user sudo right. By default, csadmin has no sudo rights in CentOS 6.4. To do that, at the command prompt, type group add sudo. Next, type in user mod -a -G sudo csadmin to add the csadmin to this sudo group. Next, type in vi sudo to open the sudo file. The sudoers file needs an entry for the sudo user. Insert %sudo, type all equals, in parentheses, all, escape wq to save the file. Now let's log out and log back in as csadmin. Type in exit, click system, logout root, logout. click on Cloudstack admin user, type in the password that you put in for Cloudstack admin, CS admin. Open the terminal window, type in sudo -i, provide the password for the root, and you're back into root. The first thing that we do after we've logged in as CS admin, we need to set up the network. So let's go have a look at the network first. If config eth0 should give us the network settings. For Cloudstack to work, we need to disable Network Manager and start the network service. Let's do that first. chk config network manager off. Note that N and M are capital in network manager, and it's a single word. Now chk config network on. Now type in service network manager stop. Service network start. Okay, once the network service is started, we need to create the Ethernet 0 network card. /cd/etc sysconfig /network -scripts vi if cfj-eth0 device equals eth0 on boot equals yes, boot protocol equals DHCP, VLAN equals no, NM controlled equals no. Press escape, WQ. Now restart this network service by typing service network restart. Now let's change the host name. Let's first verify host name by typing host name --fqdn. It shows as localhost.local domain. However, we want it as csmhost001.cloud.intr. So to change that, let's edit the host name first by typing cd vi networks network, and then change the localhost local domain to csm host 001.cloud.intr. Save the file. Now type in if config eth0, copy the IP address, type in cd.vi hosts, paste the IP address into the host file, type in csm host 001.cloud.intr csm host 001 escape wq. Now restart this network service. Type in host name csm host 001.cloud.intr. Type in host name and fkdn, and now we have csm host 001. Now do a ping csm host 001 and you will get the IP address. In my case it's 172.16.232.88. Okay, on the management host, if you remember, we added two disk drives. One was 50 GB and the other was 200 GB. Now we had used the 50 GB as the boot drive, so we need to configure the drive for NFS data for the using fdisk. So type in fdisk -L to list all the devices. If you scroll, you would see that there is an SDA of 53 GB that has a partition 1 and 2, and there's an SDB which is 214.7 gigabytes in size, but there is no partition on it. So let's create the partition for SDB. Type fdisk/device/SDB. Type in N for new, P for primary partition, 1 partition, click enter, and W to write it. This created the partition. Now we need to format it or make the file system on it. So type in mkfs -t ext3 space /device/SDB partition 1. Now that the partition has been created and formatted, it's available for mounting. So let's create a mount folder by typing in mkdir/nfs data. Then mount it by mount /device/SDB1 to NFS data. Now if you go to change your directory to /NFS data, and type in ls, you'll see that there is a loss found created. And if you do du, it will give you how many directories there are, but df dot will give you the size. Okay, now we mounted it manually, so we need to make sure that this is mounted every time the server restarts. To do that, we need to add this to the FS tab. Type in vi/etc/fs fs tab to open the fs tab file. Add /device /sdb1 /nfs data ext3 file system defaults 0 space 0. Escape. And now this will mount the file system every time the server restarts. This sets up the environment for installing the for the management server and the host server. The first server is done. Let's go ahead and now create the second server, which is CS host 001. Let's minimize this. Click on add new. Click continue without disk. Take CentOS 64, continue. Make sure operating system and version are okay. Click continue. Customize settings. Type in CS host 001. Click save. Go to processors and memory. Change it to 2 processor cores. Type in 4096. Click on advanced and select the enable hypervisor applications in this virtual machine. Next, let's resize the hard drive by clicking hard disk and changing it to 50 gigabytes. Click apply. Close the window, settings window. Next, click on CS host 001 and click startup. Once you see automatic boot in a few seconds, hit any key, select install. Once the CentOS installation is started, click next, click next, click next. Select basic storage devices, click next. Click yes to discard data. Type in cshost 001.cloud.intr. Click next. Select the time zone, click next. Give the root password. Make sure the root password is similar to the CS management server that you created earlier. Click next. Click use anyway. Select use all space. Click next. Click write changes to disk. Click on close to restart the server. The server will reboot and you will see the welcome screen. Now click forward. Forward again. Type in csadmin Cloudstack admin user. Provide the password. Make sure the password is same as the management host server. Click forward. Yes. Select synchronize date and time. Click forward. Click OK and click finish. Now click on other. Login as root. First thing we'll do is install the VMware tools. Click on Virtual Machine in the menu. Click on Install VMware Tools. Click on Install. Double-click VMware Tools. Click Extract. Click on File System. Select TMP and click Extract. Click Quit. Close the window. Start a terminal. Change to TMP. Change to VMware. Tools distribution. Type in /VMware install.pl -- default to install with as default. usr/bin/VMware -user to start the VMware client. Next, type in yum -y update to update the system. Once the installation is complete, let's go ahead and give sudo rights to csadmin. Group add sudo usermod -a -G sudo csadmin vi sudo. Insert %sudo all equals in parentheses all. Save the file. Now let's log out. Log back in Cloudstack admin. Open terminal window, type in sudo -i, provide the password for the root. Now let's stop the network manager service and start the network service. Type in chk config network manager off, chk config network on, service network manager stop, service network start. Now let's add the Ethernet 0 adapter cd/etc/sys config /network-scripts via cfg-eth0 insert device equals eth0 on boot equals yes, boot protocol equals DHCP. Additionally, we will add it as bridge cloud BR0 that Cloudstack uses by default. Let's save the file. Now let's create the cloud BR0 file. vi cloud if cfg cloud BR0. Okay, let's make sure that it has device equals cloud BR0, on boot equals yes, boot protocol equals DHCP, nm controlled equals no, and type equals to bridge. Keep that in mind that a bridge has a capital B, it's case sensitive. Let's escape this, save the file. Now we should have two files with ifcfg. You would see that we have ifcfg cloud BR0 and we have ifcfg ETH0. Next, let's change the host name. Make sure that the host name is correct, and also change it to cshost001.cloud.intr. So type in vi/etc/sysconfig network and change the localhost local domain to cshost001.cloud.intr. Save the file, type in hostname cloud 001, so cs host 001.cloud.intr, vi/etc/hosts, and add the entry for the server. My IP address is 172.16.232.189. Type in cs host 001.cloud.intr, cs host 001. Before we save the file, let's make sure, let's see what's the IP address for the management host and add that in as well. Window cs host 001. Let's log in into the server. Okay. Vi host sudo vi/etc/hosts, password. Okay, that's 189 and this is 194. We can copy this and go back to the server and paste it. Okay, now let's ping the server, ping the host server, cs host 001, and there you go. Ping the management host server, csm host 001. Okay, and it returns as csm host 001.cloud.intr. Okay, here's what we did until now. We created a Cloudstack management and a host server. We also installed the CentOS 6.4 64-bit. We updated the operating system. We granted sudo permissions to the CS admin user. And we verified and configured the server FQDN. And we also verified the connectivity between the two servers by pinging each other. Next is to install Cloudstack. So let's get started. Let's move on to the management server first. On the management server, click on Cloudstack admin and log in. open the terminal window, type in sudo -i, and provide the password. First thing that we need to do to install before we start the installation is to make sure that OpenSSH is running. To do that, type in service sshd start. Now let's do chk config sshd on to make sure that it starts every time the server is restarted. Now, before we can install Cloudstack, we need to make sure that we have the repository configured. So we type in vi/etc/yum.repos.d/cloudstack.repo. This will create a new repository file. We need to type in the following: Cloudstack in braces, name equals Cloudstack, base URL equals http://cloudstack.apt-get.eu/rhel/version 4.2. If you're installing an earlier version and it's available, you could change the version right here. Like for instance, if you need to install 4.0 or 4.1, just type in 4.1 instead of 4.2. We are going to use 4.2. Click enabled, type in enabled equals 1 and gpg check equals 0. Save the file. Now let's go ahead and install Cloudstack management first. So type in yum -y cloudstack-management. This will download and install all the prerequisites as well as the Cloudstack packages. If you want to verify, you can type in yum list installed grep Cloudstack. And it will list all the packages that are installed. One of the packages that actually doesn't get installed by the installation is the usage package. So we would install that now. Type in yum -y cloudstack-usage. Install cloudstack-usage. Let's check if MySQL is installed. And it is installed. So we can start this MySQL service by typing in service mysqld start. Type in chk config mysqld on to make sure that it starts every time the server is restarted. Now we will go ahead and change the sudoers file to add the user cloud and give it the rights to sudo. Type in vi /etc /sudoers, or type in vi sudo. The last line, type in defaults :cloud space exclamation mark re query escape WQ. Next, let's set the SE Linux to permissive. Type in vi /etc /se linux /config. Change enforcing to permissive. This will ensure that SE Linux is started in permissive mode every time the server is rebooted. To set the currently set the SE Linux, type in set enforce permissive. Next, let's configure the MySQL file. So type in vi /etc /my.cnf. Under MySQLD, insert innodb underscore rollback underscore on underscore timeout equals 1. innodb underscore lock underscore wait underscore timeout equals 600. max underscore connections equals 350. log dash bin equals MySQL dash bin. bin log minus format equals, in code, double quotes, capital ROW. Hit escape and save the file. Now restart the MySQL service. Service MySQL the restart. Now that the database is configured, we need to ensure that the database is secure. By default, there is no password set for the MySQL database in CentOS. To set up as a to secure your installation, you can type in MySQL underscore secure underscore installation. There's no password, so hit enter. Set root password equals yes. Now type in the new password. Click yes to the remaining items and we'll be back to the prompt. Now we've secured the MySQL installation. Now it's time to set up the Cloudstack database. So type in Cloudstack -setup -databases space user call cloud, password for that user. I'm using password with a capital P ASSW0RD at localhost because the database is local to the system. --deploy -as -root as equals root, the password for the root user. And hit enter. This will set up the database for Cloudstack. As you can see, it detected 188 as the IP address for management. The Cloudstack database setup. Next is to start the set up the Cloudstack management. Type in Cloudstack -setup -management. And we're done. To test it, we can open Firefox and type in localhost :8080/client. Okay, great. Now Cloudstack management server is installed. Next, let's install one of the utils that needs to be installed as part of the installation, called vhtutil. Type in wget http://aws.com/tools/vhd-util. Okay, now move this file over to the Zen folder. First, let's create that Zen folder. mkdir /vm/hypervisor/zen server. Now move the file over. mv vhd-util and copy and paste the path. Great. Now next thing that you need to do is actually set up the firewalls for this, since this is a lab for us, we can simply disable the firewall rules, the entire firewall on the host server. To disable the firewall, type in for service IP tables stop. Next, chk config IP tables off. And that is it. Our management server is set up. Now let's go ahead and set this same server or the CM host server as a host service as well. To do so, first is run yum -y cloudstack-agent. Install cloudstack-agent. This will install the host portion or the host services for Cloudstack and all the dependencies that are needed for Cloudstack. Now let's go ahead and install Word Manager. Yum -y install Word-manager space Word-viewer. Okay. Now let's install KVM by typing in yum -y install KVM. Once the KVM is installed, we need to configure the libraWord-d configuration file. So type in vi/etc/sysconfig /lib virt d make sure libraWord-d is the pound is removed in front of the libraWord-d underscore arguments. Now we need to modify the other libraWord-d file /etc/libvirt /libvirt-d.conf. We need to remove listen-tls, pound in front of listen-tls. TCP listen. TCP port. MDNS advance. Make sure it is 0. And auth_TCP, and make sure it is typed as none. and then save the file. Now we need to update the QEMU file. vi/etc/libvirt/QEMU.conf. Make sure VNC_listen the pound is removed in front of VNC_listen to ensure that VNC is listening. Let's restart the libvirt now. So service libvirt restart. Okay, libvirt was not started, so that's why it gave you failed, which is okay. Now libvirt is started. Let's make sure that it is always started at startup by typing in chk config libvirt on. Now let's start the Cloudstack agent by typing in service Cloudstack-agent start. And make sure it always is started. So type in chk config Cloudstack-agent on. And that's it, guys. We're done with setup of the host services on this server. Now that we've configured the host and the management services, let's install and configure NFS that is required for primary and secondary storage. Type in yum -y install NFS. Okay, it is already installed, so there's really nothing to do. So let's start the NFS service by typing in service NFS start. Great. Let's make sure it always starts by typing in chk config NFS on. Another service that we want to make sure is running is RPC bind. So we type in service RPC bind start, type in chk config RPC bind on. If you recall, while installing the management host server, we had created NFS data drive of 200 gigabytes. Now we will be creating the primary and secondary files for export. So type in mkdir /-p /NFS data /export /primary and then secondary. Next, we need to make sure that NFS exports the NFS data export file folder. So to do that, let's open the NFS exports file and make sure that has the entry vi/etc/exports. We need to type in /NFS data /export space star has to be read write async, no root squash, and save the file. Now we need to configure the NFS file. So let's go ahead and type in vi/etc/sys config NFS. Lock the UDP port. Mount the port. R code D port. Stat D port. Stat D outgoing port. And save the file. Now let's restart the NFS service by typing in service NFS restart. Also, we need to type in export fs export file system -RA to make sure that the exports is folders are exported, NFS folders are exported. To verify, you can just type in show mount -E, and it will show you that /NFS data /export and all the subfolders within it are exported, are shared as NFS shares. Next, we need to install the system templates so that the Cloudstack can be installed. So type in /usr/share/common/scripts/storage/secondary /cloud install sys tmp lt -m /NFS data /export /secondary -u http://d21 ifh cun6b1t2 .cloudfront.net /templates slash 4.2 slash system VM template dash 2013 dash 06 dash 12 dash master dash kvm dot q cow2 dot bz2 minus h kvm minus s password minus f. And this will download the system templates and install them in the slash export slash secondary folder under NFS. Okay, that was the final step of the installation. At this point, I would recommend that we shut down the server and take a snapshot of the server before we go on to configuring Cloudstack. So type in exit, click on system, click on shutdown, and click shutdown. Click on virtual machines, snapshots, and take a snapshot. Okay, once the snapshot is done, let's bring the server back up. Okay, the server's up. Now we can actually log in as Cloudstack admin user. I'll launch Firefox. Type in localhost ::::8080 / client. Type in admin, all lowercase password. Before we start to configure Cloudstack, there are two global variables that we need to set. Let's set them first. So click on I have used Cloudstack before, skip this guide. Click on global settings. In the search box, type local. Click on system VM use local storage. As we are going to use local storage on the server, type in true. Click yes. Click the check mark. Click close. On the search box again, type in sec storage. Click on sec storage .allowed.internal sites. This is required for templates to allow the templates to be downloaded. Our network is 172.16.232.0/24. If you have more of these, for instance 10.10.10.0 network, you type in comma 10.10.10.0/24 and hit OK. Click close. We now need to restart the Cloudstack management service. Open the terminal window. Type in sudo service Cloudstack -management restart. Provide the password for root user. Okay, the service restarted. Let's now refresh the browser. Log in again with admin lowercase password. This time we'll click on continue with basic installation. Provide the password This is the new password for Cloudstack admin account. Let's add a zone now. Click OK. I'm going to use BZ1, basic zone 1. I'm going to use the DNS server of 8.8.8. I have an internal server on 10.10.10.12. That's what I'm going to use for internal. Click continue. Now let's add a pod. I will use name as BZ1 POD1. My gateway is 2, so I'm going to type in 172.16.232.2. My net mask is 255.255.0. IP ranges, I'm giving 10 IP ranges. This IP address range is going to be used for host servers, management servers, as well as the console and storage and proxy servers. Our local storage is local, so we don't need an IP address for that. We have only 2 host servers, which is host 001 and CSM host 001, which is also the management server. However, I've given a range of 10, which should be sufficient. Click continue. Again, my guest network is gateway is 172.16.232.2. Net mask. I'm going to give a slightly larger range for this because these are the guest VMs that we will create. Note, public IP addresses and the guest IP addresses are same in a basic zone as public addresses are used for every guest. Now let's go ahead and add the cluster. We are using KVM, so we'll change to KVM, and we will give KVM CL1. You could give any other name. Click continue. Now we're going to configure the host. Our host is csmhost001.cloud.intr. Let's make sure that we are able to ping by name. Ping csmhost001.cloud.intr, and we are able to ping it. So we're going to use that, and we're going to use the root user, provide the password for the root user. Now let's add the storage. Starting with primary storage first. So our primary storage, we need to give a name for it. So we'll give primary storage 1. We're going to keep it as NFS. We could either keep zone wide or cluster wide. We're going to keep it as cluster wide. We're going to use the server. It's advisable to use, it's recommended that you use the IP address for the NFS instead of the name. So we'll use that, and then we'll provide the path. Our path is /NFS data /export /primary that we created when we installed NFS and configured it. Click continue. Now we're going to add the secondary storage. NFS server is 172.16.232.194, which is local. We're going to use NFS, and we're going to use the path as /export, NFS data /export /secondary. Now, one thing is noteworthy here is when we actually create a zone by clicking on manually. I know Cloudstack. I've used Cloudstack before, and we go into creating a zone. At that point of time, it gives us another option of actually using 2 other types of secondary storage devices, which is S3, which is Amazon Simple Storage Service, or we could use Swift. For now, but when you use the wizard, it doesn't provide you that option. It only gives you NFS. So let's continue. And now that we've provided all the configuration required for the zone to be launched, let's click on launch to create it. Okay, created the zone, physical networks, configured the physical networks, enabled security group provider, created the guest network, created the pod, created the guest traffic, configured the guest traffic, and created the cluster. Now it's attempting to add the host. If we want, we can track the progress by tailing the log file. So we can type in sudo tail -f/var/log /cloudstack/management -server.log. Okay, so this is going to tail the log file. Now let's look at it. It added the host, created the primary storage, secondary storage, and then zone creation was complete, and it's enabling the zone. It's also creating the system VMs. Keep this in mind, this step is going to fail if you've missed installing the system VMs that we installed through a URL on the previous steps. If it does fail, don't close the browser. Simply go ahead and download run the command again, make sure that the system templates are installed, and then click on continue or fix errors, and then it will go ahead and start to relaunch the installation. Once the cloud setup is complete, you'll see cloud setup successful, and now you can launch your zone. So click on launch. Okay, and that is it for the Cloud Zone installation. Okay, what we need to do next is to verify everything's functional as we configured. So the first thing we'll do is we'll look at the dashboard, and we see a zone created, BZ1. When you click on it, it'll give you the resources used by the zone. Click on home again. Now let's go and see where it is created. Browse scroll down, and you'll see on the left side infrastructure. Click on it, and you will see that we created one zone with one pod, one cluster, one host, one primary storage, one secondary storage, and 2 system VMs. There are no virtual routers as yet. Virtual routers will be deployed automatically when you create the first virtual machine. Now let's click on zones, view all under zones, and click on the zone, and you will see that the zone information is available here. As we configured, the external DNS was 8.8.8.8. Internal DNS for me was 10.10.10.12. Okay, so we look at the compute and storage. This is how it looks. As you can see, the zone has pods, pods has clusters, clusters has hosts, and then clusters also have primary storage. Then we have UCS, which we've not used, but we have the secondary storage as well. Okay, you click on the physical networks, you will have created only one physical network. All go into the L2, L3 switch, guest, management, and storage, and also the network providers. When you click on it, you'll see that we are using a virtual router. We could use a NetScaler external, Nicira, Big Switch, Bare Metal Pixie, and we are also using security groups. These are disabled. Some of these services can only be used with advanced networks. Let's go back by clicking zones, and now we can look at the resources. As we saw before, under dashboard, there are 2 system VMs. Both of them are running. Let's make sure we can connect to them via console. You click on one of the systems, click on console, and we have the console working. Okay, go back to BZ1 and look at the settings. These are the zone-wide settings that we had set up. We have okay. These are global settings for zone itself that affect all of the systems within the zone. Okay, we've left this as default. Okay, another thing that we need to make sure is that our default template, which is CentOS for 5.5 64-bit, no GUI KVM has been installed and it's available. You can go click on templates and then go to CentOS, click on it, and you'll see that the ready state says yes and the download is complete. If this doesn't show up as download complete, then you would know that the system VM is unable to connect to the internet for some reason, and we'll have to troubleshoot that. Otherwise, either it will show downloading or it will show you downloaded, installed, and ready state as yes. Now let's go ahead and look at our network. We have one default guest network. In a basic zone, we can only have one default guest network. Okay, we click on the IP ranges. We don't have any used at all at this point, and these are the configurations for our network. Let's look at storage. We have not used any storage as yet. There are no volumes or there are no snapshots created. We can look at our affinity groups. If you want to, we can create another affinity group. Here's where you create the instances. On the left side, when you click events, you'll see all the events. And you can click on the drop down to see any alerts. You click on projects. Projects are a specific space that you create within a cloud instance to subdivide as a project, and you allocate certain resources out of the cloud into the project. So you can create a new project by clicking projects and add new project. For instance, if you have different departments within an organization, you could create department ABC by creating projects, or create multiple clouds, multiple domains by creating department 123 and then project 123 within that cloud. Click on accounts and you'll see all the accounts. By default, we only created admin account. Click on domains and you'll see domains that we created. We only have the root domain at this time, which is created by default. We have regions. We have only one region, which is local. We've already seen infrastructure. We've already seen global settings. We also have certain offerings that we can create: the compute offerings, the system offerings, the disk offerings, and the network offerings. In compute, we can see we by default get a small and a medium instance. If you click on either one of them, you will see that it has defined the parameters for it. As you can see, a medium instance consists of one CPU core using shared storage type, 1 gigahertz of CPU, and a memory of 1 gig. A small instance also uses shared. However, it uses only 500 megahertz of CPU and 512 megabytes of memory. Disk offerings, we have small, medium, large, and custom. These are the system when you create, or an instance when you create, is divided into two disks. One is the root disk and the other is the data disk. Root disk is only one in the system. However, you can add as many data disks, and the disk offerings are for the data disks. So as you can see, by default we created the system creates small, medium, large, and custom. Now that we're familiar with the interface, let's go ahead and create an instance by clicking Instances and click Add Instance. You could either use an ISO file or a template. However, we have not added any other templates, so we have only one template, and we have definitely not added any ISOs. So we click on Template, click Next. This is the default template that was installed. Click Next. We can either create a small or a medium instance. If we want to create additional instances, we can create a larger instance by going into offerings and then adding compute offerings for a large or extra small server. Click Next. We don't need to use the secondary or the disk data disk offering that we saw before. We have 4 options. So we'll keep it as no thanks. Click Next. We haven't created any affinity groups. Affinity groups are basically that you can ensure that a server, a particular virtual machine, is always run on a specific host or a set of hosts. This is to ensure licensing compliance, as well as making sure that it is run on a more powerful system. So you could create the affinity and anti-affinity groups under the affinity on the left side in the menu item. We don't have any, so we'll click Next. We have only one security group that we've defined. Security groups are basically a IP configurations or IP filterings that are applied on each and every system that to isolate the servers between different shared or in a multi-tenant environment. We only have one default security group. The default security group right now is a context of admin. We have only one user, so and one domain. Keep this in mind that if you have different domains, each domain, when you create a security group, which is created under the network, that would, the context of that group would only be for that particular cloud or domain. And we'll see that when we create additional domains. Click Next. Click Launch. This will create the server. Now here is the security groups. We've only one called default. We can actually create different security groups, one for application, one for database, and one for web if we want to separate the types of or the roles for the servers. Okay, now it's starting up. If you click on it, you can see more information about the system. You can view the volumes. As you can see, there's only one root drive that is created. You can take snapshots. You can view the affinity groups. We don't have any. You can view the host that it is running on. As you can see, it is running on this host. This is the IP address of the server. We gave a range of 221 to 235, so it took 223. We can attach secondary IP addresses, but we don't have that configured. Look at the security groups that it's part of, only default security group, and look at the statistics. As you can see, it was 1 into 500 megahertz system. We can connect to it by either looking at a terminal window, connecting externally using SSH, or clicking on the console to view the system. Okay. Looks like it's still starting up. the login for the default VM is root and lowercase password. There you go. Our first virtual machine is up and running. Okay, let's close the console now. If you go to storage, you would see that there's only one root drive created. Instances, there's only one server that we created, root-s1. Okay, now let's see how to delete this server. We can either shut down or stop or reboot the server by hovering over the plus sign or clicking the root and then using the menu on the top. As we saw, we actually took a console. Now another thing we can do is we can take a snapshot of the server. Snapshot is a backup of the disk at a point of time. So when you click on snapshot, you can specify a snapshot. Additionally, you can actually take a snapshot of if the VM is running, you could take a snapshot of the memory as well, and it'll restore that as well when you restore it. You can attach an ISO to it if you want to launch and install or mount a CD-ROM. You can reset the password for the system. You can migrate to another host if there are two hosts. And you can view the console as we saw before. And we also saw you could go look at NIC cards, NIC configuration, security groups, and the statistics. You can view volumes, snapshots, affinity groups, view hosts, or even reset the VM. Now we're going to stop the VM by clicking stop and click OK. Next, we're going to delete destroy the instance. You can click on destroy. Okay, once the system is destroyed, it really doesn't go away, and you could change the default settings for it to stay for or disappear within a certain period of time. But right now, once even that you destroyed the system, the instance is still available. It shows as destroyed. This allows you to restore in case you want to restore it from a temporary state or the deletion state it has been marked for. Okay, next what we're going to do is we're going to create a domain. We right now have only a root domain, so let's hypothetically say that we have a client come in and the client needs to be, it's an XYZ company, and we need to provide them a domain or a area for them to work with. So we're going to click on root, and then we're going to click on add a domain. We're going to call it XYZ Cloud. Don't need to specify the domain. Click OK. And there you go. Our XYZ Cloud is now being created. Now that the XYZ Cloud is created, we need to create an account for the user or for the cloud. We click on add an account. We're going to call this XYZ admin. Provide the password for it. Provide the email for it. XYZ admin at xyz.com. First name admin, last name admin, or user. We can specify the domain. Automatically we have XYZ Cloud. If you have separate domains within that'll show up as well. We'll specify it as an admin. We specify the time zone for it. I'm on the Eastern time zone, so I'm selecting that. And simply click OK. Okay, created the account. Now once the account is created, you can view the users within that account. By default, it uses the same user account, creates a user account by the account name, user by the account name, which is XYZ admin, so that XYZ admin can log in. Additionally, we can provide new users by clicking add user to that account. So type in XYZ user 1, password for that user, email for that user, XYZ user1 at xyz.com, user, this one is 1, select the time zone, click OK. Now we've created two users, admin and user. Okay, user has only user privileges. Admin has admin privileges on that particular domain. Now let's log out and log back in as the XYZ admin. XYZ admin, password for the admin. Now you need to make sure you provide the domain name as well, which is, in our case, it's XYZ Cloud. Click login. XYZ Cloud. You can type in XYZ admin, password, and the domain as xyz-cloud. Click login. As you can see, the infrastructure is not available and the service offerings are not available to the subdomain of the root. Only root has those admin rights. Other than that, we can create regions, we can create domains, we can create accounts, projects, look at the events, look at the templates, look at networks, storage, affinity groups, instances, and look at the dashboard. As you can see, the dashboard's different than the root admin user. Now let's log out and log back in as a user. XYZ user1, password XYZ-cloud. There you go. This is just a user. Okay. Let's log out that user, log back in as XYZ admin. Now go into network, create a new security group, can add, call it applications, click OK. Add another security group called web. One more called databases or database. Click OK. We can also create an affinity group, provide an host anti-affinity if we want to. We have only one host, so we don't need it. If you want to create subdomains, as you can see, you cannot see the root domain over here. We can create additional domains underneath it if we want to. Wait a minute, it doesn't allow for domain to be created, subdomains to be created. It only allows for accounts or the projects to be created within that domain. So you can create a new project. You can do invitations of the project as well. Go to instances. You can add an instance. Select the instance. Click a small instance. Create next, next, next. As you can see now, there is database, web, applications, and default now that we can use. We can be part of all these or just one group. So let's say if you're creating a application server, we would just create as applications and click next. Type in XYZ-S1. Click launch. Great. Click on console. And you see that CentOS is coming up. While this is getting installed, let's go back to network and go to security groups. Click on the applications that we selected. Now we want to allow a incoming ports to be opened, which is under ingress rules. We can specify the port, let's say SSH port for connectivity, which is port 22. We type in starting port 22, ending port 22, which is a TCP/IP port. CIDR is the account that would need access to this. We're going to give everyone access, so we're going to type in 0.0.0.0/0. That means anyone can connect to this port. Click add. And now this opens up the 22 port for that server. Let's go back to instances, launch it again. We have the instance. Now we're going to connect. You can close this, minimize it. We have the log running, so we're going to do Control C to come out. Now we're going to type in sudo SSH. Look at the IP address of the server. Root user at the IP address. Now it will connect to it. You specify yes and provide the password, all lowercase. And now we connected to root XYZ-S1 server. Okay, now let's move on to CS host 001 server. Log in and configure it to be added to the cloud. Okay, now let's set up the repository for download of Cloudstack. We can either type in or copy the file. We will first create the file via etc/repos yum.repos.d/cloudstack.repo. Now let's go to the CSM host and copy the file from there. Save the file. Now install the Cloudstack agent by typing in yum -y install Cloudstack-agent. Once the installation is complete, let's go ahead and install KVM and Virtual Machine Manager. So type in yum -y install KVM space virtm manager and virt viewer. Hit enter. Okay, next let's go ahead and change the config files for SE Linux to permissive. So vi/etc/se linux/config. Now let's run set enforce permissive. Now let's change the sudo file. We can copy the sudo file from the other machine. So let's go ahead and move to CM host, log in, and close this. We need these two lines. Copy them. And paste them into the host CS host 001. Let's now edit the libervirt, the conf file, vi/etc lib virtd slash lib virt.conf. Remove tns listen. tns listen tcp. TCP port. Change the mdns underscore adv equals to 0. Remove the auth SSL TCP and put it to none. Hit escape and save the file. Next, let's change the libvirt file, which is vi/etc/sysconfig/libvirt file. We need to just remove the libvirt underscore args equals to -- listen. Remove the £, save it, restart the service, libvirt restart. Make sure libvirt starts by typing in chk config libvirt on. This will ensure that it starts every time the server is rebooted. Now let's go change the qemu.conf file, vi/etc/libvirt/qemu.conf. You need to make sure VNC listen is 00. Okay, we need to restart libvirt one more time. Now we need to disable the firewall. Type in chk config IP tables off service IP tables stop. And finally, configure the Cloudstack agent to start automatically by typing chk config Cloudstack-agent on chk service Cloudstack-agent start. And this is it for setup of the Cloudstack agent or the host server. Let's go ahead and try and add this server to the management. So go to CSM GMT001, log in, open your Firefox. Log into Cloudstack. Remember, the password is new, okay? Let's go ahead into infrastructure. Click on view all under hosts. Click on add a host. Type in either the IP address or the DNS of the host. So let's find out if the DNS server DNS settings is correct. If config ETH0, it's 189. Host name --FQDN. Okay, ping cs host 001.cloud.intr. Okay, great. Now we need to make sure that the management server is able to ping the server. You can cancel this, minimize the browser. In the command prompt, type in ping cs host 001, and it is working correctly. Okay, go back to Cloudstack, and now let's start adding the server. Click on add host, cs host 001, user is root, password, and click OK. We are getting an error where the host is not connecting. To troubleshoot, let's look at the log file, and I'm going to search for cs host 001, and I see that it is attempting, and it's telling me that it's unable to connect to port 22. So let's go ahead and make sure that the CS host is running the SSHD service. So ps -ef grep SSHD service status service SSHD status. It is stopped. Okay, so we need to start the OpenSSH to make sure that it's able to connect, because the server connects at that port to add into the management. So let's start it by typing service SSHD start. Make sure that it always starts by chk config SSHD on. Now let's go back and try to add that server back in. Click add. Root password. Click OK. Now it's trying to create the server and add it to the cluster. While it's adding, we can look at the log on cs host 001 vi or tail -f/var/log/cloudstack agent.log. Okay, let's look at if it. Go to Windows, CS host m host 001, and CS host has been added. Now click on it to get the statistics and detail of the server. It is enabled. Just type is routing. It's 189. We have 4.2 version. We can look at statistics of the server: 2 CPU, 2.79 gigahertz, 3.74 GB. Now, we have two servers, or two hosts running in Cloudstack. Now let's go ahead and see if we can actually move the XYZ S1 server to a different host. Click on migrate to another host, click OK to start migration. Okay, now that the migration is complete, let's verify that. There you go, it is on CS host INTR. Another way of verifying it is going into infrastructure and looking at the CS host 001 server and looking at the instances. There you go, the xyz.s1 server is now running on second host. This basically completes our Cloudstack configuration. Folks, this brings us to the end of the Cloudstack training. In this training, we learned about Cloudstack basics. We learned about preparing the base systems. We learned about configuring and installing Cloudstack services. We also built our first cloud environment with a basic zone. And we also learned about Cloudstack basic administration. If you have any questions or if you have any feedback, please feel free to send it to me at bobby@headnetsolutions.com. Thank you for viewing this video.